All right, now, in doing this quiz, we had so many answers that were so wrong. I want to set this straight, and this is found on many of the previous videos that were set forth. In order to justify that triangles are similar, we have three options to choose from, and those options include angle, angle, side angle, side, and side, side, side. Those are the theorems that we have in order to justify similarity. So when you do a flow chart, essentially that's just listing out reasons in order to show how two triangles are similar, and your conclusion is because of one of these three at the end. And so to do a flow chart, what we need to do is first look at our picture and recognize I have a triangle here and another triangle here. Now, in order to show this, what I'm going to do is I'm going to, first of all, rule out the possibility of using angle-angle similarity. And what I mean by that is I'm not given any set of angles that are the exact same. Now, there's a little caveat to that. Both angles share this one up top. It's overlapping in both sets of triangles. So that is shared by both of them, but that is one set of angles. There's not a second set of angles that is the same in both triangles. So I cannot use angle-angle, nor can I use side, 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 because I do not have three sets of sides. I have 1, 2, 3 sets of sides in one triangle, but in the blue triangle I have these two on the side, but I do not know the bottom length x at all. So I cannot use side, side, side because I do not have three sets of sides. So what I need to do then is use the side angle side similarity condition, because I've been given two sets of sides here and the angle in between, and I'm going to use that to justify similarity. So if I use side angle side to start my flow chart, I'm going to put SAS on top, and I'm going to put bubbles here that represent each of those separate conditions of side. So when I say side, this first S, I'm going to list two sets of sides that are proportional. What I mean by that, this side length of FD, I'm saying is proportional to or corresponds to FP. So I'm going to say FP divided by FD. Okay, and that is going to be equal to the ratio of the entire length of FP. That would be 18. 10 plus 8 is 18. That corresponds to FD. That is 10, or 1.8. Okay, so that's a number, 1.8. What needs to happen then is the other set of sides that I am listing, and the other set of sides is this one over here, that needs to have the exact same ratio of 1.8. So notice I listed the longer side length in the numerator of my circle here. So I'm going to start by doing Fj, that corresponds to Fh. So I'm going to say Fj divided by Fh. Those ratio of sides is equal to 14.4 divided by 8. 14.4 divided by 8. Okay, now when you divide that in your calculator, you end up getting 1.8, which is exactly what we want. We want both of those numbers to be the exact same. We want 1.8 and 1.8, those ratios of sides to be the same. Then finally, what is the angle that we are talking about? The angle that we are referring to is this angle that is shared between both triangles in the middle, and that would be angle F. So the measure of angle F is equal to measure of angle F. Here are three pieces of information that I have. I have a set of sides and another set of sides and an angle in between those two sides being the same, and the sides are proportional to one another, meaning that they have the same enlargement factor between sides. So therefore, this is enough information that we have stated in order to justify that those two triangles, triangle FDH, is similar to triangle FPJ. And this last little piece that I wrote is called the similarity statement. And this is the last piece of my flow chart, taking all of these important pieces of information, and it all is all pointing to this piece of similarity. And I'm going to say that this is by side angle side similarity. So this thing again right here is called the similarity statement, and that is saying what two triangles are similar. And you don't need to write the actual word similarity statement, but that's what that is called. and it is by side angle side similarity. Now moving on to the second part, it says using similar triangles above, calculate the value of x. Well, in order to do that, we're going to set up proportions, and proportions is a fancy way of saying fractions. So what I'm going to do is I'm going to set up a fraction of sides that I have, and then one of those fractions is going to involve x, and one of them is not. I know that the fraction of x over 6, these two sides here correspond to one another. This side length of 6 is in the same spot as this one of x. So this is the same ratio of HD over JP. They're in the same spot. If these triangles are similar, which we proved in the previous example that they are, then this fraction of x over 6, that has to be the same ratio as taking one of the other side lengths, and I'm going to use this one right here, the longer side length of 18. That needs to be the same ratio as 18 divided by 10. These two fractions have to be the same if the triangles are similar, which they are. Now the only thing is I don't know what x is, so I'm going to cross multiply and I'm going to solve for x. And when I do that, I'm going to get 10x equals 60 and 48 makes 108, and solve, and x is going to turn out to be 10.8. And so I set up a proportion of sides in order to solve for my missing variable, and I ended up getting 10.8. And that was using the idea of similar triangles up above. Lastly, find the missing side length for each triangle. This was not good at all on our quiz for those of you who submitted it. And in these problems, we cannot use Pythagorean theorem. We have to use this idea of what we've talked about with the tangent ratio. And we said that the tangent ratio is a ratio of sides. And so tangent is merely a ratio of the opposite side divided by the adjacent side. And so we write that the tangent of some angle theta is equal to the opposite leg divided by the adjacent leg, and what we do is we fill in the missing components that we have from a given triangle. So for example, in this triangle on the left, this is the angle that I am looking from. It's my reference angle, 50 degrees. That is going to go right here. Okay, so I can set up an equation that says the tangent of 50 degrees, or the slope ratio of a 50-degree right triangle, is equal to the opposite leg, the leg across from it, which in this instance is 10, divided by the adjacent leg, or the leg that is next to the 50-degree angle. And that goes right here. So I'm going to put that length down here of x. Now in order to solve something like this, I'm going to make this numeric value on the left side a fraction, and now I'm going to cross multiply. And that's going to give me x times the tangent of 50 degrees equal to 10. Now the tangent of 50 degrees, this is just a number. Okay, that's nothing in particular. You type it in your calculator and you're going to get a number. And I'm not going to do that yet. I want to get x all by itself. So in order to get x by itself, what I'm going to do is I'm going to divide both sides by the tangent of 50 degrees. And that looks like this. Divide by the tangent of 50, divide by the tangent of 50. And in doing so, then I'm going to be left with x equals 10 divided by the tangent of 50 degrees. Now you're going to bust out your graphing calculator or your scientific calculator. It should be able to do this for you. And what you need to do is make sure you type it in. And as I've stated in previous videos, that you need to make sure you are in degree mode when you calculate this value. So tangent, or 10 divided by the tangent of 50 degrees, as I type it into my calculator, is 8.39. And that would be the value of x, which is 8.39. So going on to the second triangle, again, I have another angle of reference. In this case, it's 58 degrees. The side across from it that's not the hypotenuse is the opposite leg. So y is the opposite, and 15 then is going to be the adjacent leg. So I'm going to set up another equation using the tangent ratio. The tangent of 58 degrees is equal to the opposite leg, which is y, divided by the adjacent leg, which is 15. So again, this comes from this equation right here. This is the equation that represents the tangent of an angle. It's a ratio of sides. And so in order to solve this, again, I'm going to put it over 1, and then I'm going to cross multiply. And when I do that, I'm going to get 15 times the tangent of 58 degrees is equal to y. And so now I can just type that into my calculator. 15 times the tangent of 58 degrees. And in doing so, I end up getting 24.01. And that would be the actual answer for y in that instance. So this is the answers to quiz number 1, something that is very important to be able to prepare yourself for your test on Thursday. If you have questions, please reach out and ask. Your test has to be submitted by 10 p.m. on Thursday. Feel free to email me, inbox me via Canvas, and or stop by office hours. Stay safe and stay healthy.